today we're going to work on permutations and combinations. And one of the first things to remember when you're working with permutations and combinations is that permutations, order doesn't matter. So let's say, for example, we have one set of balls, A, B, and C. We also have a second set of balls, C, B, and A. Now, when you're working with combinations, it's different because order matters. So if you have ball sets A, B, and C, it would be the same as sets C, B, and A. So you would have to choose one of those two to make your one because they're considered the same. So the first thing we're going to look at is permutations. Now, I already have it labeled out here, but I'll go over it with you as I explain it. So, as I said, permutations, order doesn't matter. So let's say, for example, we have 4 competitors in a singing competition. We have Kyle, Michelle, Susan, and Logan. So when you're working with permutations, you're trying to find an arrangement, how many different arrangements you can come up with when order doesn't matter. So I use their first initials of their names, and we're going to go over it, and we're going to count how many there are, and that's going to tell us exactly how many permutations there are for these 4 competitors. So our first set would be Kyle, Michelle, and Susan. Our second set would be Michelle, Susan, and Kyle. Third set would be Susan, Kyle, Michelle. The fourth set would be Susan, Michelle, Kyle. Our fifth set would be Michelle, Kyle, and Susan. And our sixth set would be Kyle, Susan, and Michelle. Now, as you can see, they all have the same letters pretty much, but they're still considered a set of their own. So moving on, number 7, we have Michelle, Susan, and Logan. The 8th set is Susan, Logan, Michelle. 9th set is Michelle, Logan, and Susan. The next set is Logan, Susan, Michelle. Our 11th set is Susan, Michelle, Logan. And our 12th set is Logan, Michelle, and Susan. Again, as you can see, the letters are just repeated, but they're still considered different sets. Moving on, 13 is Susan, Logan, and Kyle. The next one is Logan, Kyle, and Susan, followed by Kyle, Susan, and Logan. The next one is Kyle, Logan, and Susan. 17 is Logan, Susan, and Kyle. And 18 is Susan, Kyle, and Logan. Again, the letters are repeated, but they're still considered separate sets. Moving on to 19, Logan, Kyle, Michelle. 20, Kyle, Michelle, Logan. 21, Michelle, Logan, and Kyle. 22, Michelle, Kyle, and Logan. 23, Kyle, Michelle, and Logan. And finally, 24 is Logan, Michelle, and Kyle. Now, 24 is our answer, and out of those 4 competitors, if only 3 of them were to go into the competition, and we wanted to see how many permutations we could come up with, it would be 24. Now, combinations, as I mentioned earlier, is a little bit different. Now, when you have combinations, you have to remember that order does matter. So, I'm going to erase permutation up here, and I'm going to write combination. Okay? So, let's write combination right here. Combination. Okay? And order does matter in this instance. Order does matter. And 24 would not be our answer, so we're going to erase 24. Now, as I stated, combinations, you can't have the same sets repeat over and over again. So if we were looking at this set here, Kyle, Michelle, our first set was Kyle, Michelle, Susan, Susan, Kyle, Michelle, Michelle, Kyle, Susan, and Kyle, Susan, Michelle. When you have combinations, those are all considered the same. So we'd have to choose which order we would want to use. So if we choose, let's say we choose Kyle, Susan, Michelle. Okay? So if we were to choose Kyle, Susan, Michelle, these would become non-existent in combination because they are considered the same as this one. Moving on to the next one, it's the same process. When you're looking at combinations, Michelle, Susan, Logan, Logan, Michelle, Logan, Susan, Michelle, Logan, and Logan, Michelle, Susan. So if we were looking through our second set, let's say we wanted to go with Logan, Susan, Michelle. So if we were to choose this one, we would have to mark all the other ones out because in combinations, those are considered the same. Looking at our set 3, we have Susan, Logan, Kyle, Kyle, Susan, Susan, Logan, Logan, Susan, Susan, Kyle, Logan. So let's go with Kyle, Susan, and Logan. So if we were going to go with this one here, we would have to mark out all the other ones because they are considered the same in a combination. Looking at our final set here, we have Logan, Kyle, Michelle, Michelle, Logan, Logan, Kyle, Kyle, Logan, Logan, Michelle, and Logan, Michelle, Kyle. So let's go with Logan, Kyle, and Michelle. So if we're going to go with the first one here, all these become non-existent because in a combination, these are considered the same. So in all, we have a total of, let's count, 1, 2, 3, 4. Okay? So our combination set is 4. So we can only have 4 combinations in this set of singing competitors when we want only 3 to go into finals. And that is how you figure out permutations and combinations. Thank you so much. Good night.